That's not for me. Is that for? Hello guys and welcome to it. This is our very first Easter School exam revision live. I'm so excited. My name is Abram and I hope you guys are so excited as I am. I know that you guys want to chat with us and we're here to help you guys learn more and learn extra. Remember guys, this show is proudly sponsored by MTN SA Foundation and supported by the Department of Basic Education. With me today is Dina and we're doing mathematics. Dina, how are you?
Hello, Abraham. I'm really well and really excited for this afternoon show.
I'm so excited in a way that the mindsetters on the page as well, they're telling me how they're excited, they want to send through their questions, and you know, we're here to help them. What are we doing?
Today we are going to be looking at patterns with specific attention to sequences and series in the arithmetic as well as geometric domain, and we hope that we'll carry on to some problem solving as well.
Of course, guys, and as mindset, we've got this learner's workbook that the questions that Dina will be going through are from this workbook. We've took some questions from you guys. There's some nice questions that will help you guys. So be on the look. Our Facebook page to chat with me is simple. Facebook.com/LearnExtra. Make sure you like our page. Share it with all your friends. And on that page, you'll get the notes links. If you can't see them, go to our website, which is learn.mindset.co.za. Otherwise, on Twitter, I'll be taking some of your tweets at LearnExtra. We ready to rock and roll, Dina? Let's do it.
Thanks, Abraham. Let's get started with our patterns. You will have remembered from your grade 10 as well as grade 11 work that you tackled some linear as well as some quadratic patterns. And now in grade 12, you would have looked at some arithmetic as well as geometric patterns. So what I'd like to do this afternoon is draw up a little mind map of all the formulae with the various types of patterns, and straight after that go into some practice questions. Now I know that there are some lovely summary notes on the web page, so if you go and download that, you will get some lovely worked examples as well to go through, just as a matter of revision. So for now, I'd like to just start off by just brainstorming a little mind map of what it is that we're going to be covering this afternoon. Just need to get hold of a page, so let's get a clean page. There we go. Okay, so this section on patterns involves looking at mostly quadratic, which I've already said are on your notes, but the ones that we look at in grade 12 are what we label arithmetic, and we can look at the term and we can look at the sum of the terms. So the general term that we focus in is a plus n minus 1d. And the sum of all the terms in a sequence, which we then call a series, is 2a. Let's just not get ahead of ourselves here. Let's just, 2a is part of the formula, but it's not the start of the formula. So the sum would be n over 2 into 2a plus n minus 1d. And just a little note, grade 12s, you will get a formula sheet with your examination at the end of the year, and there are all these formulae to go back on. But it's good to memorize them just that you can fall back as a checking mechanism, and that you're not copying things blindly, because you can lose time and marks if you just try and copy from a formula sheet. So do try and memorize them. Then we get, let's use the pink, we get geometric patterns, and they will also have a general term, and the general term will be a r to the n minus 1, and the sum would be a into r to the n minus 1 over r minus 1. Okay, so the two patterns that we're looking at, the reason we say arithmetic is because we're going to be adding the same number over and over again. So it's a pattern that we're developing. So for example, if we start with 2 and we add 3, we would get 5, and if we add another 3, we'd get 8, and another 3 would get 11. So if we keep adding 3, we're creating that sequence. Whereas geometric, we would multiply by 3. So if we took 2 times 3, we got 6, then 6 times 3, we'd get 18, 18 times 3 is 54, so you're tripling all the time. So any sequence where you're multiplying, we call geometric. And any sequence where we're adding the same number all the time we call arithmetic. So those are the two key sequences. And then we want to look at just two further things that we use in both these in these patterns, and that is our sigma, which allows us to find the sum of both these sequences. And this is the capital letter in Greek that is the S letter. And so that stands for adding up all the terms. So every time we see that sign, it's telling us to add up all the terms. And the way that this works is that you will have the general term next to it so that you know how each term of that series is composed or how it's made, and then you can add up all the terms. So any of these two could have that symbol as your sum. And then in terms of the geometric, we also get, let's see if we can get another color, there we go. We also get the sum to infinity, which is just A over R minus 1. So only a geometric series will have a sum to infinity, and it will be a particular type of sequence. It's where your ratio is sitting between 1 and -1, and obviously the ratio can't be 0. So any sequence that is made by multiplying by a half, 3/4, etc., you will find that that sequence will tend to infinity. So that is really a snapshot of all the formulae. Like I say, in the summary on the webpage, you'll find worked examples with all the formulae well listed. So if you find that you don't have a grasp or you just want extra practice, do go there. What we're going to do now is look at some of the questions in the practice section, which Abraham's already said come from the workbook. So I'd like to tackle some of those. And we're going to look here, firstly, at the sequence -2, 3, 8, 13, 18, 23, 28, 33, 38. I think that they've given us something to think about, because we first need to establish what kind of sequence do I have. Is it arithmetic? Am I adding the same thing all the time? Am I multiplying this by the same thing all the time? So to determine that, how much am I adding all the time, I would take the difference of the two terms, and to determine what I'm multiplying, I would do the inverse. I would divide each of the two terms. So if I say 3 minus 2, I would get there's a difference of 5 here, there's a difference of 5 there, there's a difference of 5 there, there's a difference of 5 there. So I think that it looks like we have a difference of 5, whereas if I divide 3 by 2, it's not the same as 8 by 3, it's not the same as 13 by 8. So it's definitely not a geometric. And how would we know that it's not quadratic? Well, if our first difference is constant, then it cannot be quadratic. Because remember, quadratic has to have the second difference as constant. So its first difference wouldn't be constant. But because we've taken the first difference, we can see straight away there are 5 units between these, there's 5 units between those, there are 5 units between that. And I would encourage you for you to do that and to say that 3 minus -2 is equal to 5. So that you're actually looking at your first difference. And then to look at 3 and 8. And 8 minus 3 is equal to 5. And we do that 3 times, and 18 minus 13 is equal to 5. So that when they're asking for the 100th term, we have to determine, how did we get this 5? How did we find that? Well, the first thing is that we established that the sequence is arithmetic. And the reason is that we have a constant difference. So if the sequence is arithmetic, then straight away we know that the 100th term, because it's term, 100th term, is going to be the first term plus 99 differences. Okay, so the first term I have is negative 2, but to then find the difference, I have to show how I calculated that. So I would say that my constant difference is always the second term minus the first, which is equal to 3 minus negative 2, which is equal to 5. Okay, so now I can substitute. My first term is negative 2. I have 99 differences. I've worked out that the difference is 5. And I then can work out that that would be 500 minus 5. So that's 495 minus 2 would be 493. Okay, let's just double check. Our 99 times... Okay, it looks like our calculator is not doing its thing. Okay, that would be the 100th term. If we check here, 99.5, since my calculator is not cooperating, is 45, and 4 is 49. Okay, so that's correct. So we've been able to establish the 100th term as 100. So what the sequence is then telling me is that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is T9. So if I keep going all the way to TR100, I'm going to find that the 100th term has got a value of 495. Okay, so next up is what is the sum of the first 100 terms. Now, in this case, there is a formula for the sum of 100 terms. It's an arithmetic. I always work, remember there are 3 types of sequences you work with. So if you've already established that it's arithmetic, then we would state that the sum of 100 would be n over 2 multiplied by 2a plus n minus 1d. So we get 100 over 2 into our first term is negative 2, and we had 99 differences. 100 minus 1 is 99. So we can now say, right, if I add up all those 100, I'm adding minus 2 to 3 to 5 to 8, etc., then I'm going to get 50 multiplied by negative 4 plus our 495. So that would be 491. So that would be 5. So that would be 24550. Okay, because 5 times 1 is 5, 45 carry 4, 5 4 is 20, 24. Okay, so it looks like if I add all those 100. So if we go back to the sequence, what we're saying is that if we take minus 2 and we add 3 and we add 8, we add 13 to that and we add 18 to that, so you can see that that would have been 1, that would have been 9, that would have been 22, that would have been 40. So if you keep adding all the way to 495, we're getting a sum total of 24550. Okay, so that's the power of this formula. It helps to take a large sum of numbers and just find that sum quickly without sitting and adding each one by itself. So that would be an example of a arithmetic sequence. Okay, so if we look at something in terms of the application of this, if we look at the 13th and 7th terms, and the language that's used is very important. So it is the term that we're looking for of an arithmetic sequence of 15 and 51. So we don't get these 13, 7, 15, and 51 values all mixed up. So if it's terms, I'm talking about T. And I'm talking about position 13 and I'm talking about position 7. So position 13 is 15, and position 7 is 51, because they use the word respectively. I never knew what that word meant until in English. It's a sequence of numbers that if you're writing the first list and the second list, you want the two first ones to match, and then the next ones, etc. So it's not a random selection. So the 13th and 7th are 15 and 51. It means that the 7th can't be 15 and the 13th can't be 51. Okay, so we are given those values. Which term of the sequence is now equal to 21? So now again, I'm talking about a term. Which term? I've got to translate it into a formula. That's Tn. So I want to know, when is a plus n minus 1d, when is that equal to negative 21? Okay, but I don't know the first term. It's missing. I only know the 7th and the 13th, and I don't know what the difference is either. So I've got to go and do some calculations, because in order to solve for one variable, I need to make sure that the other two I have found what they are. So I need to do a little bit of calculation. If the 13th term is 15, then what is that translation? That is a plus 12d. And if the 7th term is 51, what is that translation? A plus 6d. So I've got a simultaneous solution over here, where if I take the first one minus the second one, I get 6d. And if I take the difference between that, that would be minus 36. 15 minus 51 would be minus 36. So d is equal to negative 6. So I would indicate that's equation 1, that's equation 2, and I would subtract the 2, which then helps me because I can go back and substitute in here to find out what a is. So a would be 12 times 6 would be negative 72, plus the 15, I would get 72 plus 15, which would be 87. So a is 87. Okay. Yeah, because the difference is minus 6, so you start with a high number and then you decrease it. So now I can come and find out what n is, because I've got a as 87, I've got n minus 1, which I want to find out, and I've got this one as minus 6 is equal to minus 21. And in that way, I can now solve for n and determine which term would be minus 21. We can see that the 13th is 15, so it's decreasing. So it's got to be a term that's more than 13, because we're seeing that it starts with a high value, it gets lower and lower because we're adding minus 6 all the time.
Right, thanks, Dina. I think it's time for a break.
I think so too.
There. Right, guys, I know that some of you are suffering or struggling with geometric patterns, but Dina is here for you guys. Send your questions through on our Facebook page, which is facebook.com/LearnExtra. We'll see you after this break. Welcome back, awesome mind sitters. Guys, where have you been? If you just joined us now, we're doing mathematics, and with Dina, she's on fire today, ready to tackle all your questions, and I'm ready to help you too, guys. Go to our Facebook page, facebook.com/LearnExtra. Like our page, share your comments and your questions, and I'll read through some of what you guys have been saying on the page. Remember, this show is proudly sponsored by MTN SA Foundation and supported by the Department of Basic Education. Now, on Facebook, Dina, this is what the mindsetters are saying. Our mindset, we've got this mindset who's always been on the page. His name is Njabulo Talet. Today, it's his birthday, and he's watching the show. So, a big shout out to you, Njabulo, and happy birthday. We were nearly twins, because my birthday is tomorrow. And this is what he says. He got an A for life sciences, maths, and physics this term, last term. So, congratulations.
Good start,
bro,
good
and
start.
Keep on working hard.
Good.
Right, let's continue with some of the
Happy
questions.
birthday and all the best for the rest of the year. Keep it up. Keep it up.
Awesome.
Okay, I hope that first section on arithmetic and geometric has really gotten us thinking about how patterns are working in terms of using and utilizing the formula. Remember that a lot of the pattern work is trying to model, give us a little model on what, or a maths model on what this English language is trying to tell us. So hidden In this language, or embedded in this language, are some of those key facts that we've got to extract. And once we've got that model out, then it's just a matter of solving some simple equations. So let's get to the next question on the practice questions. Okay, well, this time round, they start off by saying it's geometric. Well, that's fantastic because we can already locate what our formula should be. The 6th term is 243, and the 3rd term is 72. Determine the constant ratio. Okay, so remember what we said. What is the model to get the 6th term as 243? That would be T6 is equal to, it's geometric, so it's AR to the n minus 1. And T6 is equal to 243. The 3rd term is 72. So again, the model for this is T3 is AR squared is 72. So we've been able to give maths to the language, maths to the language. Not that maths is not a language, but we've been able to give it some formulae. Okay, so now in this equation, AR to the n minus 1, which should be 5, is equal to 243, and AR squared is equal to 72. We are going to solve simultaneously, but because we have an exponential in both of these equations, in geometric series we've got a different way of solving that is much more efficient. And that would be to say, let's take equation 1 and let's divide it by equation 2. And in that way, you can see that AR5 divided by AR squared is actually equal to R cubed. And we can now divide 243 by 72. And hopefully, with a special touch during the break, we are now going to have this magic machine. Okay, which has got 243 divided by 72. Okay. Okay, 27 over 8. So R cubed is 27 over 8. But that's R cubed. So what would I do to just get R? I would take the cube root, so it would be 3 over 2. So that would be my R value. Okay. That being R, I can now work out the sum of the first 10 terms, because the sum is what I need of the first 10. So the first 10 would be the sum of 10, would be A multiplied by R to the n minus 1 over R minus 1. Now I just want to clear up this. If the formula has been given and I haven't substituted anything in, then that's Sn. But if I now want to work out the sum of 10, then n is 10. So A, don't think I've worked out A yet. No. So we need to work out A first. So A multiplied by, we have worked out R, it's 3 over 2 to the power of 10 minus 1, and we need to multiply that by A, we're coming to that in a moment, divided by 3 over 2 minus 1. Okay, so our little A, we can work out over here, would be A is 72 divided by 3 over 2, so it's times 2 over 3. So that would give us 93, 24 times 2 is 48. So it looks like A is 48. Let's check. 72 times 2 divided by 3, 48. Right, so we've now got that A is 48, so we can substitute in here as a 48. And we get 3 over 2 minus 1 would be a half, so that would be 96. We just clear that and just get our equation over here. 96 multiplied by 3 over 2. Okay, we want get out there. 3 over 2 to the power of 10. And we want to subtract 1. We want to close that bracket. Equals. So the sum is that very large number. Let's just get a decimal for it. 5439,8. 5439,8. Okay, so 5,439 is the sum of those first 10 terms in the geometric sequence. Okay, then let's consider the sequence. A half, 4, a quarter, 7, an eighth, 10. As a mathematician, you should have picked out some patterns speaking to us. What are they? I can see that 4, 7, 10, the second, the fourth, and the sixth terms actually have a difference of 3, and I can see that a half, a quarter, an eighth is a geometric where I'm multiplying by half all the time. So we've interspersed the odd terms with the even terms, and the odd terms give us a sequence, and the even terms give us another sequence. Interesting. We can really make up a combination, what we would call a combination of patterns. So not just arithmetic, not just geometric. It's quite a favorite with the examiners. I find at the end of the year they usually embed one in the other and you've got to extract it. Okay, and that usually happens because if you say a half times 8 would be 4, and if you say 4 times 8 you get 32, so it's definitely not geometric. And 4 minus a half is 3.5, and a quarter minus 4 is not 3.5. So it's also not arithmetic, so you know that straight away. But if you take it at a glance, you can see the half, quarter, 8 standing there, and 4, 7, 10 also standing there, waiting to be, begging to be worked with. So if we had to carry on, our next one would be a half of an eighth, which is 16, and plus 3 would be 13. So in the first question, when you are supposed to write down the next two terms, there they are. And then if you wanted to calculate the sum of the first 50 terms, that's very interesting because the sequence is made up of 2. So it's got the blue sequence made up of T1, T3, T5, and then it's made up of the yellow sequence, 4, 7, 10, 13. So it would be T2, T4, and T6. So the 50th term would land up on a sequence, the arithmetic sequence, and the 49th term would add up, would be the geometric. So we're actually looking for T25 of our arithmetic, which would be our first term, and it wouldn't be T25, we'd like the sum. The question asks for the sum, so the sum of my yellow sequence would only be the 25 terms, because it would be 1, 2, 3, 4, 5, 6. So you'll see, just taking 6, that you would add only 3 of the arithmetic, and you'd add 3 of the blue. So you're actually adding half of the terms to get to my 50 terms. So the sum of 25 would be 25 over 2, and you would have 2 times 4 plus, and we have 24 differences, and the difference was 3. We're adding 3 all the time. Very, very careful, grade 12s, with your substitution. Really take extra care. Is my difference negative? Is it positive? If it's negative, remember to use brackets, because very easy section to work with numbers. It's really not abstract. It's quite practical. But we can make a lot of little careless errors, so we've got to really pay attention to our accuracy. So that would be 25 over 2 into 8 plus 72. So that's in total 25 divided by 2 times 80. And that would give us, oh dear, we got in 2 times there. Okay, 25 divided by 2 times 80. It would be 1,000. Okay, and then the blue ones, the sum of 25 of the blue sequence would be geometric, so it would be A into 1 minus r to the 25, which is 3 what did we get our r as? A half. So 1 minus a half. Okay, let us just fix that up there. And we need the blue, so it's a half to the power of 25 divided by 1 minus a half, which is a half. So our sum of 25 would be very small. It would be 1 comma something. 1 minus 0.5 to the power of 25. Because that, yeah, so it would be about 1. So the sum, because that half, a quarter, eighth, that fraction is getting tinier and tinier, so it's getting closer and closer to 0, so it's becoming a negligible number that you're actually adding. So the sum total of those two sequences would be 1001. Okay, and then I'd like to look at sigma. Determine n if such is happening. So grade 12s, can you decode what this is all saying? Okay, so this is really shorthand. This formula over here is a shorthand notation to tell me four important things. The first one is that sitting here is my general term. So that is my Tn. So Tn is 6r minus 1. And you know how powerful that is? With that Tn, I can tell you exactly what any of the terms in the sequence are. That's the function of the general term. So if I want the first term, I'm getting 6 minus 1. If I want the second term, I'm getting 12 minus 1. If I want the third term, 18 minus 1. So I can tell that the sequence is what kind? I'm adding 6, I'm adding 6. The sequence is arithmetic. Fantastic. So that's how powerful that is. So the first thing I've got is I've got my general term. Then it's telling me that in order to get my sum of 4, 5, 6, so that's my sum total, so S of n is 4, 5, 6. Okay, very important. That's the second thing I've got. The third thing I've got is that I must start substituting r equals 1. In fact, the formula is slightly wrong over here. This should have been 6n minus 1. Because if it's r equals 1, it says that start substituting at n equals 1. So I wouldn't start substituting at 2, at 3, at 4. I would start there. I would substitute there. So my sequence starts. So this is where my sequence begins. Okay, my sequence is beginning, starts at T1. And where does it end? It will end there. So I'm going to add on. So it looks like this: T1 plus T2 plus T3 plus all the way to Tn. So I'm adding a certain number of terms I'm adding together, and I'm getting 4, 5, 6. The question is, how many terms am I adding up to get to a sum total of 4, 5, 6? So notice how much decoding I've had to do to understand what is hidden behind all these numbers and variables. Okay? First one is the sequence and how it's made up, the general term. The second one is my sum. The third one is where do I start with my sequence, and the last one is where do I end with what is my last term. Okay, so now if I know that it's arithmetic, I will know that Sn, which I've called with this color, I think, Sn is 4, 5, 6. I know that if it's arithmetic, it's n over 2 multiplied by 2a plus n minus 1d, and I know that that's all equal to 4, 5, 6. Okay, so I can now substitute in what I know. My a, my first term, what did we get it as? We worked it up here, is 5, and I'm adding 6. So it's equal to 5. I know that I'm solving for n, and I know that my difference is equal to 6. And I can now solve for n. So, if I'm multiplying n in here, I'm going to get a quadratic. So I'm going to get a lovely quadratic equation over here. I'm going to double it over there. N into 10 plus 6n minus 6 is equal to 912. It's double 4, 5, 6. 10, 11, carry 1, yeah. So then we get 6n squared. 10 minus 6 is 4, plus 4n minus 912 is equal to 0. It's definitely a multiple of 2, so it's 3n squared plus 2n minus 456 is equal to 0. This is also divisible by 3, so it's n squared. But then I'm going to create 2/3. Never mind, let's keep it like that. And let's try and see if we can find some fact. Actually, let's not try. Let's actually use the quadratic formula to revise the quadratic formula. So n is equal to minus b plus or minus the square root of b squared minus 4a. Where's the minus creeping in? Why is it creeping in there? Times 3 times minus 456 over 2a, which is 6. Right, in our fabulous little machine, let's get it working. So if we have a 4, actually let's take the square root of 4 plus 12 times 456. What do we get? We get 74. So n is going to be equal to minus 2 plus 74 divided by 6, or n is equal to minus 2 minus 74 divided by 6. And that would be 72 over 6, so n is 12, or negative 76. N must be an integer, so that's a fraction, so it's not applicable. So there would be 12 terms. Lovely quadratic equation in patterns. I think I'm putting it back to Abraham.
Thank you so much, Dina. Guys, something that you didn't know, after the break I'll be telling you more about how you can enter our competition to win yourself a Chevy Spark. Last term we gave away 1 car to Dimakato, and you could be next. Stay tuned to find out more after this break. Welcome back, guys. Now, I told you before the break that you could win yourself a Chevy Spark, a cool Chevy Spark. This is brought to you by Safeways K53 and Mindset and Chevrolet. Guys, they have partnered together to give you a car. All you need to do to be a Bright Spark, you must get yourself an app. So last year, I got my license. Yay! I was so excited, but still I was unsure of some of the road signs. You know this, Dina, you get your license, but when you get on the road, it's a different story. So what I did,
Real life.
Yeah. So what I did, I bought the app, guys, of which you can get that app for yourself. Even right now, it's at a reduced price, 59 Rand, guys. So guys, go to Samsung Galaxy Store or Google Play Store and get yourself the Safeways K53 app. It has got some cool functional videos that will help you through step by step. So guys, this is going to help you. It has helped me. It needs to help you too. Then after that, enter the competition. It's called Be a Bright Spark competition. More details are on our Facebook page, or also like the Facebook page of Safeways, which is facebook.com/Safeways K53. Dina, I've got a question for you.
Yes, go for it, Abraham.
All right. This one is from Avumile Lohoho, saying, how do we get the next 2 terms of the sequence?
Okay, in the combined sequence, remember that the odd terms will be giving us one sequence and the even terms will be giving us another sequence. So if we looked at straight away what is going on here, a half, a quarter, an eighth, we can see that each of these terms is half of the other. So a quarter is half of a half, and an eighth is a half of a quarter. So the next term must be a half of an eighth. So the 1/16th is half of an eighth. And the yellow terms, 4, 7, 10, we can see that we're adding 3 to get 7, we're adding 3 to get 10, so we must add 3 to get 13. So it's 10 plus 3. So the blue sequence is geometric with a ratio of a half, so I'm multiplying by half all the time, and the yellow sequence is an arithmetic sequence, so we're adding 3 all the time. So it just depends on which sequence you've taken. You can have 2 arithmetic sequences, you can have 2 geometric sequences embedded in each other, but oftentimes that's quite difficult to tell apart. So they'll often give you like a fraction one where you can see exactly what the ratio is, and then they'll give you arithmetic that's easier to extract as well. Great.
Nice one.
Thanks, Mindsetters. Keep bringing those questions. It's lovely to be able to answer all your problems and to make you become more confident in the mathematics. Okay, let's see what's up next. We have, I know something around sigma. We've done something around sigma. Let's go on to that last topic of the geometric, which is consider the series. Now, you might have seen I've been interchanging the word sequence with series when I've actually been meaning that I'm adding the terms. That's just because at grade 12 level you'll find that they'll ask you to find the sum and they'll ask you to find the term. So it's a loose wording that we talk about when we say series, because a series is really the sum of the terms that are embedded in a sequence. So if I wanted, I could say to you, add up the terms in the sequence. So that would be the same thing as saying that you've got the series. So as long as you understand the terminology around adding, the word series doesn't really play that much of a vital link. So they have those said consider the series. So when we're writing it out, remember, just before the break, we said that this is the general term. So if this is a general term, that is Tn. So Tn is 2 times a half x to the n. In other words, T1 would be what? 2 times a half to the x. So it would just be x. T2 would be 2 times a half x squared. So it would be, I'm just going to write like this, it's 2 times, okay, I'm not even going to expand it, just so that you can see the pattern. Over here, I'm also not going to expand it, just so that it's more visible to us what is actually happening. So this is a half x to the 1. Okay, and then we have T3 is 2 times a half x cubed. So I think that you can see what is happening from the blue term to the yellow term. I've taken that a half x and I've multiplied by another half x. And over here, to make it cubed, I've multiplied by another half x. So I can tell that these 3 terms form what kind of a series? They form a geometric series where my ratio is a half x. Okay, so I'm saying that every single term is made by multiplying the previous term by a half x. Okay, now that is really what this general term is. Then it says I'm going to start my series at n equals 1, which we've already done, and I must go to where? What does this mean? Okay, this means that I'm going to infinity. Now, earlier we mentioned that the sum to infinity is a selected sum. It's not the sum of a quadratic. It's not the sum of a arithmetic. It's the sum of a geometric, but one that converges. Now, what does that mean? That as you add more and more and more terms, that sum isn't growing. Because if you think about it, when we talk number sense, the more we add, the bigger the number gets. And that's usually what's framed in our minds. However, in maths, in true mathematics, that's not always true. Because the more you add on the negative side, -2, -3, -5, -8, it's getting smaller. I'm getting a smaller sum. So sums can get larger, sums can get smaller. But sums can also converge. That means it's tending towards a number. And that special kind of sum only exists when our series converges. And that happens, again, when our ratio is between 1 and negative 1. So if I multiply a sequence by 3, and I'm creating a larger and larger number, you can see that as I'm adding, I'm getting bigger. Okay, tripling, I'm getting bigger. But if I multiply by a third all the time, if I multiply a third by a third, I get a ninth. If I multiply a ninth by a third, I get 1/27th. So I'm getting a number that's getting closer and closer and closer to 0. So my sum is therefore going to tend towards a number. Okay, so for which values of the series will series converge? And for this, grade 12s, we have a special mathematical formula for that. The series only converges if r is between 1 and negative 1. Okay, so the moment you see series converges, automatically you attach a special ratio. It's not for any ratio, it's for a ratio between negative 1 and 1. Okay, so if that's the case, and we've already said that our ratio is a half x, then I'm going to say that a half x must be between 1 and negative 1. And for which values of x will the series then converge? So if we multiply by 2, any value of x between negative 2 and 2 for this sequence will make it converge. So if I substitute, what is this telling me? If I substitute a value of 3, x equals 3, this series will diverge. That's the opposite of converging, tending to or away from. So an x equals 5 and x equals 10, any x outside this domain will get my series to diverge. Okay, so if they said, if x equals 5, calculate the sum to infinity, what would your comment be on that? You would immediately say that's impossible, because this series is only going to converge if x is smaller than 2. So if you're telling me x equals 5, it will not exist. Okay. Now, you may be tempted to say, oh yes, I'm very clever. I know that the sum to infinity is a over 1 minus r. So you then take your a, you take your r, and you substitute it in, and you get a value. Yes, your formula may give you a value. However, that value is meaningless. It actually doesn't exist. So you can't just apply a formula to a context and hope that that formula will give you something logical. You actually need to argue whether that formula is valid or not. Okay, so we would say for the yellow one that this would be impossible to calculate. No sum to infinity, or sum to infinity does not exist as x is bigger than 2. Okay, and you would have said that from the previous statement. So the fact that they're giving me a half, I'm happy to calculate the sum to infinity. So the sum to infinity is equal to a over 1 minus r, and our a is, we've found out already, it's 2 times a half x, 2 times a half x, and our ratio is 1 minus a half x. And they've said if x is a half. So if x equals a half, then the sum to infinity is 2. A half of 2 is 1, times another half would be a half, and then we're dividing it by a half of a half is a quarter, and so that would be 1 minus a quarter, which would be 3/4, and so our sum to infinity would equal times 4 over 3, so that would be 2 over 3. Okay, so what we're saying is that if we add T1 and T2, the series, and T3, and we go all the way to infinity, to an infinite number of terms, that our sum of infinity tends to 2/3. Now, we often don't use the arrow to indicate tends to, but that's what we're saying, is that it will all converge towards that 2/3. Doesn't matter how many more terms you add, it will actually be
Unfortunately, Dina, we have run out of time. We'd love to still continue, but exam revision doesn't end here. The guys should still watch, and if they do have some questions, visit our website, land.mindset.co.za/help desk, and see some of the frequently asked questions. But guys, we have to end it there, Dina. Thank you so much, and thanks to you guys for watching, and a big thank you to MTN SA Foundation for proudly sponsoring the show, and of course Department of Basic Education for supporting this show. We love you guys, and peace.
Bye.